All right, let's look at the repeated quadratic factor number 1. Right? So inverse Laplace transform of s over quantity s squared plus k squared is equal to 1 over 2k t times sine of kt. Right? Let's prove this. Right? So first, I'm going to let f of t be t sine of kt. All right, then I'm going to take a couple of derivatives. So you have f prime of t. Oops, f prime of t is equal to product rule. So this is the first guy. This is the second guy. So by product rule, derivative of the first is 1 times sine of kt and plus t times, and the derivative of sine of kt is k cosine of kt. All right, so we got that, and the second derivative. So second derivative would be, and derivative of sine of kt is k cosine of kt plus, right, another product rule here. So I'm going to group this guy as the first one. This is the second one. And derivative of the first is k, times cosine of kt. And plus, actually it's going to be minus, right? So you have a kt originally, but derivative of cosine of kt is negative k, so you have another k, sine of kt. All right, and if you clean this up, you're going to get, let's see, we can just combine the first two terms. You have a 2k cosine of kt minus k squared t sine of kt. All right, then we can take the Laplace transform of both sides. So you have, if you take the Laplace transform, we know that since this is a second derivative, so you have s squared, capital S f of s, minus s times lowercase f of 0, minus f prime of 0, and is equal to, alright, so cosine of kt, so 2k is just a number, so you have a 2k, and Laplace transform of cosine of kt is s over s squared plus k squared, and minus, alright, k squared is just a constant, so I put it here, alright. T sine of kt is actually exactly the same thing as f of t, so we can, Laplace transform is capital f sub s. Right? So since we're looking for, let's say, Laplace transform, we're looking for capital F sub s. Right? But first, we know that, let's see, we want to find f of 0. And if you plug in 0 for t, it's obviously 0 there. And also, if you do f prime of 0, then you see that, let's see, if you plug it in here, sine of 0 is 0, 0 times anything 0, it's all 0. So which means that this guy is 0. and that guy is 0. So we can actually just scratch them out, right? So we can just bring this guy over to the other side, combined with s squared, capital S of f of s. So we have, let's see, you have s squared plus k squared, capital F of s, is equal to, and the only thing left is 2ks over s squared plus k squared. All right, then we can just simply divide it through by quantity s squared plus k squared. So you have f of s is equal to, maybe I'll write it this way. So f of s is Laplace transform of t. So this is original one is sine of kt is equal to, you have a 2ks over, you have s squared plus k squared, quantity squared. All right. And so if you rewrite that, so I'm going to actually go up here. If you rewrite that, you can write it as Laplace inverse Laplace transform. Just try to go backward. You have 2ks over quantity s squared plus k squared squared is equal to t times sine of kt. All right, only difference is you have this extra 2k there. We can simply divide it through by 2k. Remember that the Laplace transform and inverse Laplace transforms are linear. So if you take the, you can pull the constant out. So you have inverse Laplace transform of s over s squared plus k squared squared is equal to 1 over 2k t times sine of kt. Right? That's how they came up with this formula here. So this is a repeated quadratic factor formula, number 1. Right? That's it. I hope that this was clear.